What is up, guys? Welcome to the Computer Information Highway for your Java programming tutorial number 34. And in this video, we're going to be taking a little bit of a different path. We're not going to be so much focused on the programming and more of what we can do with the programming. I don't know if you guys could see, but I like my projects to be useful, extremely useful in the world of computer science, at least. I try to make it relevant in some way or another so you're not just doing simple Hello World applications. Granted, I know I had to do that in the beginning, but I don't want just like one video to take care of just like one really small example. I want to make sure everything is thoroughly understood as much as I can. And that's why you hear me repeat a lot of what I say over and over again, is I just want to reinforce some of the concepts to you so that it's easier to understand. Um, so in this video, rather than starting up a really big project, we're just going to go over a really important topic or a really important algorithm in computer science. And the topic that we're working with is sorting, and the algorithm that we're going to be using is our merge sort. And basically, sorting is important because when we're working with computers and we're working with databases, we generally have a large number of a large number of entries in our databases, and sometimes we need a really fast way to take all the information and sort it into a way that makes it easy for us to find stuff later on. Um, and so if we have hundreds of thousands of numbers, say in an array or whatever type of entry we have, um, we want to use an efficient sorting algorithm in order to uh, put it all in ascending order as quickly as possible without it taking too much time. Um, and some of you guys might know of another way you can sort that I'm going to skip because I don't like the idea of sorting that way. And it's where you just take a list and iterate over the entire thing twice and just swap places over and over and over again until the whole thing is sorted. But it's extremely inefficient because it requires you to go through the entire data set twice, which essentially gives you, um, like if this had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this has 10. It would take 100 iterations before it would complete sorting uh, one list of 10 numbers, which is really inefficient. And that's where the merging or the merge sort and the sorting algorithms come in. So go ahead and get into the merge sort. Basically, I'm going to start off with the most simplest of cases and work my way up from there. I'm kind of just going to block that off because I'm going to be working with like very easy numbers to begin with. Um, Actually, you know what? I don't mind using these. It's fine. I'm not going to use all of them though. So I'm going to start off with the very smallest case possible, and that is if we have a list of if there's just one entry, if we have an entire list and it just has one entry in it, that's what we're going to be working in it. And what merge sort does is it takes two sorted lists and sorts them. But so if we have this one list and it only has, let's just say, one number in it, or we can do 9. If it just has this one number in it, this one list is already considered to be sorted. So there's no reason for it to go through any like sorting any further because it's already considered to be sorted in this list. If we were to have a second number, uh, basically what the program is going to do is it's going to take the number of elements that we have, in this case it's 2, it's going to divide it in half, and it's going to put them in their own individual list. So let's just call this L1A, and it's going to be 9, and we'll call this L1B, and this is going to be 2. And going back to the original list that we had, which was just L1 of 9, we pretty much said that any list of size 1 is to be considered already sorted. Uh, so let's just call... so since we have uh, 2 lists that are broken up into size 1, we can say that both of these lists are already sorted in their own list. So in list 1A, 9, since there's only one element in it, has to already be in its correct spot. So it's just 9. And it's the same thing with B. 2 is the only element and it's already in its correct spot. No reason for us to have to switch it with anything. So these are considered to be sorted. And what we do from there is we iterate through each of the values of A and each of the values of B in both of our sorted lists, and we compare them. So basically we're going to have a sorted list that's going to be the same size as our original unsorted list. And we're going to go and we're going to start at L1A. It's going to check the first index and it says, okay, is 9 greater than, or is 9 less than 2? Because we want to be checking if it's less than, if we're going to put it in the smaller location. So if 9 is less than 2, we're going to put it on the left. If not, we're going to take the value of L1B that we're looking at and we're going to put that one on the left. So since 9 is less than 2, we're going to be putting 2 on the left-hand side, and then we're going to be putting 9 on the right-hand side. So this is now considered a sorted list. This is our sorted list of 2 numbers, and that's how it works at a small level. And we can push that a little bit further. Let's add a few more numbers to it. So we're going to say, we're going to bring back our list. We're going to say that our list is going to be, oops, we're going to say it's 9. Oh, I did 9 and 2. I probably should have done 9 and 15, but whatever. So we'll do 9, 2, and we'll do 15 and 1. Yeah, so we'll do 15 and 1. So if you see here, we have a larger list, and it would require us to break this down even further than we did before. So we have to split it up into like 2 different parts. The first is going to be to split the list in half, which is what we can do. We just split that in half like so. And then we say, okay, this is going to be our list 1, and let's call this our new list 2. So we have our list 1 and our list 2. I'm going to go ahead and put it down. So we're going to do what we did before with our previous list of just 9 and 2, and we're going to do exactly the same thing. We had our SL1 A, or we just had our L1A and our L1B. And we learned that after putting in the information, we had 2 and 9 as our outcome. So this becomes our sorted list. And then we move down to L2, which is going to be the right side of our original unsorted list. And it's going to break that one down into 2 lists as well. So we have L2. Let's call this SL2 because that's what we're going to be figuring out. And let's try to be a little bit consistent. Great. So we put in L2A and L2B. And we're going to be checking the same thing with this situation. So we know that 15 is going to be our first list, and 1 is going to be in our second list. And is 15 less than 1? Since it's not, we're going to be putting 1 in the first spot, and then we're going to be putting 15 in the second spot. And finally, what we're doing is if we're given SL1 to be 2, 9, and SL2 to be 1 and 15, we basically are going to perform the same thing on these 2 sorted lists. So we have, let's call this our super sorted list, because this is going to be like our final sorted list or whatever it is. So we're going to look at the first index, since this is going to, and it's going to look at the first index for both of them to start off. It's going to check if 2 is less than 1, and since 2 is greater than 1, so 1 is less than 2, we're going to be putting 1 in our first spot. And then it's going to increase the count of the number that we used, or it's going to increase the index of the number that we used, since we have to go through each iteration of each of our lists. So this is going to move up to the 15 now. It's going to check the 15 as the next number. So it's going to say, is 2 less than 15? And since 2 is less than 15, we can put 2 in as our next number. And then it's going to perform, and then it's going to increase the index like it did previously, and we're going to move up to checking 9. So now it's going to check if 9 is less than 15, and since it is, we can put in 9. And 15 being our last number, we can just put in 15. So the sorting isn't too bad. Uh, the programming is going to be a little bit it's going to be a little bit weird because we're going to be using recursion more than once in the same function. And that's because we're going to be recursively moving through our sorted list 1 and our sorted list 2 and breaking it up into as small of pieces as we can, and then merging small sizes of 1 with each other. Um, so you can actually see that with our lists, we'll be moving down the left side more often, or we'll be moving down the left side first, and then we'll be moving down the right side. And the reason is because what we're doing is starting off with our longer list of 9 to 15, 1. It's going to break down into the left and right side, so we'll have 9 and 2, and then 15 and 1. And then rather than moving to the right side, we continue down the left side and it splits up 9 and 2. Oops, I'm just going to make that a couple of them. And then it's also going to split up, it'll go to 9 and 2. And then it will see since 9 is only of one size and 2 is only of one size, there's no need to split either of those up. So it moves up 1 call, which was the 9-2, and separated into the 15-1, and then it checks the right side. So whenever it goes to the right side first, though, it's going to check the 15 first. So it's going to go 15, and then it's going to go 1. And that's how it ends up splitting up. So the two recursive calls that we end up making are with our first list following down the left side, and our second list following down the right side. So I know there wasn't really too much going on in this episode with programming, but I am, in the next video, we're actually going to be programming this. So I hope this video gets you started with the intuition behind the merge sort, and I will see you guys in the next video. If you liked it, go ahead and like the video. If you didn't, whatever, go ahead and thumbs down. No big deal. Whatever, I'll see you guys next time. Thanks for watching.